All right. So this is a different set of identity. In You can see the format of this particular identity. We have the sine of an angle plus the sine of another angle. So one of the basics of trigonometry is we have several identities, which is always very important for students to be very much familiar with them. So we have these four different identity, and they all come in different forms. You can see this one is the sine of an angle plus the sine of another angle, while this is the sine of an angle minus the sine of another angle. Now for this one, we have the cos and then the cos. This is positive, this is negative. So, and this is the resultant of each of all these scenarios. So if you look at a very vivid example of the application of what we have here, you can see the sine of an angle here. In this case, we have 6x being the angle, and we are asked to add this sine with this sine. Now, I want you to know that mathematically, you cannot add them just using normal algebra, because this angle here is different from this angle here. The only time when you can decide to imagine you have sine 6x plus sine 6x, then you can go on to add them, and that will be 2 sine 6x. But in this case, you have an angle here and a different angle here, which is a perfect application of what we see here: the sine of an angle plus the sine of another angle. So in this case, when you are using this identity, all you have to do is to just fix in the very first angle here and the second angle here divided by 2, and then the cosine of the first angle minus the second angle divided by 2. So let me show you let me work it so you can see more clearly. So when we have a question like this, what we do is we'll just have it like this. Since we are dealing with this particular situation, so our sine 6x plus sine 4x will be equals to 2 sine, we will have 6x plus 4x divided by 2. Then the cosine cos 6x minus 4x divided by 2. So this is how we solve questions like this. In this case, we have 2 sine 6x plus 4x, we have 10x over 2. And we have cos 6x minus 4x, that will be 2x divided by 2. We go on to solve this, we have 2 sine 5x cos 2x divided by 2 will be x. And this gives us the final answer for this particular question. So that means we can conclude that the sine of 6x plus 4x is equals to what we have here. This is the way you solve situations like this. Let's see a different example. What if you're given a question of this form where you're told to find the sine of an angle 6x minus the sine of 2x? Well, in this case, you have to go and check the identities and look for the one that matches this particular scenario. We can see that this identity of sine C minus sine D, that's the sine of an angle, C here representing any angle and D here representing a different angle. So this matches up with this identity. So all we have to do is to go on to say that sine 6x minus sine 2x will be equals to 2 the cosine of C plus D. The cosine of C plus D that will be 6x plus 2x divided by 2. Then sine, we have 6x minus 2x divided by 2. So what we will have here is 2, the cosine of this will be 8x over 2. Then sine, this will be 4x over 2. So in this case, we'll be having 2, the cosine of 8x over 2 will be 4x, and then sine 4x over 2 will be 2x. So we can see that our result when having, so the sine of 6x minus sine of 2x will be giving me a value of what we have right here. So I'd love you to evaluate the following very quickly. So I'd love you to attempt these two questions. Investigate what your answers will be for the cos of 6x plus the cos of 4x, and then the cos of 6x minus the cos of 2x. So this is how we make use of these identities under trigonometry. So once you see a question that has anything to do with situations like this, all you need to do is remember your identities and make use of them. So you don't have to do too much. Just fix them up into the identities and you will get the perfect answer. All right, guys, thank you for watching. Hope to see you in the next video. Bye-bye.